but let me make sure I get it before my period. Okay, today we're going to look at slopes of parallel and perpendicular lines. We've already looked at slope of a line recently in this semester, and basically we know that slope is the rate of change of a line. It's sometimes referred to as rise over run, and we have a specific slope formula that helps us find the slope. So these are the different ways that we can go about finding slope. Again, you can find it using rise over run. So this is 1, 2, 3, 4. And we do -4 because we're going downwards. And then 1, 2, 3, 4, 5. And so our slope would be -4 over 5 in this instance. We can also plug it into the slope formula where we identify both of the points. This is and then that's what you can plug into your slope formula, where this is your x1, your y1, and this is your x2 and your y2. So those are the different ways we can go about doing this or looking for this. So basically that is the slope. But today we're going to look at the slope of parallel and perpendicular lines. So when two lines are parallel, their slopes are equal to each other. So the slopes of parallel lines are equal. So basically we have these equations, and they're in the form y equals mx plus b. And the m represents our slope. Again, we've looked at this before. And so because these two lines are parallel, we want them to have the same m values. And so what you'll notice is the m of this orange line is -5 over 3. And in order for the other line to be parallel to that, we want it to also be equal to -5 over 3. And that is in fact the case. That's what we see here. And so because of that, we can determine that these two lines are in fact parallel. So the slopes of parallel lines are equal. The slopes of perpendicular lines, on the other hand, are negative reciprocals of each other. So in order for two lines to be perpendicular, intersect at a 90-degree angle, we want those two slopes to be negative reciprocals of each other. And so here the slope of the orange line is 3, and the slope of the bluish line is -1 over 3. And if we were to multiply those two together, we would get -1. Now, how do you find the negative reciprocal? Well, in order to find the negative reciprocal, say we're trying to find the negative reciprocal of 3. Well, what you do is first you take 3 and you create it into a fraction. So 3 over 1 is the same thing as whole number 3. So we take it into a fraction, right? Because 3 divided by 1 is 3. Next thing you're going to do is flip the fraction. And then after you do that, you negate it. So just flipping the fraction is finding the reciprocal, but we want the negative reciprocal, so you want to negate it. And so that is a way to find -1 over 3, which you just identified is in fact our negative reciprocal of 3. Okay, so again, the slope of perpendicular lines are negative reciprocals. So whenever we're asked to find these slopes, what will be usually given is we're given a specific slope and we're asked to find the slope of a line which is perpendicular, or find the slope of the line which is parallel. So here's our given. And so I want you to determine the slopes of the lines which are parallel. But we just discussed that M1 will be equal to M2, so those slopes will be equal to each other. So that means these slopes are the same. Parallel lines have the same slope. Now what if I wanted to find lines which are perpendicular to these given lines? Well, what I want to do is find the negative reciprocal. So again, if I have a whole number, I'm going to put a 1 under it. Then I'm going to flip the fraction, then negate it. When I already have a fraction, then I'll just flip the fraction and negate it. So remember, flip, then negate. You flip it, then negate it. So change the sign. Same thing here, we're already in a fraction, so just flip it, negate it. Here we have a whole number, so 4 over 1. Whenever you have a whole number, just do it over 1, flip it, and negate it. So these would be all of our perpendicular slopes. Okay, so again, you may be asked to find the slope of a line which is parallel, so you'll just keep the same slope. or the slope of the line which is perpendicular, and so you want to find that negative reciprocal. Okay, any questions still about parallel or perpendicular line slopes? Questions, concerns? Okay, now we're just going to discuss briefly about horizontal and vertical lines. So let us recall that horizontal lines have a slope of 0. So their slope is equal to 0, and vertical lines have an undefined slope, so basically those slopes would just be undefined. Well, what we'll reference here is that all horizontal lines are perpendicular to each other, and all vertical lines are perpendicular to each other. So today I have this graph. This is a horizontal line. Basically what this is telling me is if I were to draw a bunch of different horizontal lines, all those lines which are horizontal, if they are in fact all horizontal, they will all be parallel to each other. They'll never intersect. Same thing goes for vertical lines. If I create a bunch of lines here which are all vertical, if they are in fact vertical to each other, then they will never intersect. They will be parallel lines. However, if I were to take horizontal lines and draw a vertical line, then what I notice is that horizontal and vertical lines are all perpendicular to each other. They all intersect each other at right angle, 90 degrees. And so that's what this is telling me here. All horizontal lines are parallel. If all the lines are horizontal, then they are parallel. All vertical lines are parallel. If all the lines are vertical, then they're parallel to each other. And horizontal and vertical lines are perpendicular to each other. So if I were to include both the horizontal and the vertical lines, those would all be perpendicular to each other. Okay, any questions here? Remember, parallel means they never intersect. And perpendicular tells us that they intersect at 90 degree angles. Okay, now we're just going to look at two more things. We're going to look at the perpendicular transversal theorem. This basically just tells us if two lines in a plane are perpendicular to the same line, then they are parallel to each other. So basically, if I say that K is perpendicular to T, and I also say that L is perpendicular to T, then what I can gather from that is that because those two lines are perpendicular to the same lines, then those two lines K and L must be parallel to each other. So that's what this is telling me. And I'll write this here. If K is perpendicular to T and L is perpendicular to T, then K and L must be parallel to each other. And that's the perpendicular transversal theorem. Okay, any questions about this one? If two lines in a plane are perpendicular to the same line, then they are parallel to each other. We also have the perpendicular line transversity theorem. And this basically just says if two lines are parallel to a third line, then they are parallel to each other. So if E and F are parallel to each other, and G and E are parallel to each other, then what that tells me is that F and G must be parallel to each other. So if two lines are parallel to the same line, then those two lines must also be parallel to each other. So if E is parallel to F and G is parallel to F, then E and G must be parallel to one another. Okay, any questions here? Okay, so what did we go over today? We looked at parallel and perpendicular lines and their slopes. We learned that the slope of parallel lines are equal to each other. M1 is equal to M2. And we learned that perpendicular lines slopes are negative reciprocals of each other. So if I were to take M1 and times it by M2, what I would get is negative 1. And remember, we find the negative reciprocal by switching that fraction and then negating it. Okay, any questions about anything we looked at today? No? Okay. Okay, if there's no other questions, you guys may log off, and I'll see you tomorrow for some practice problems. Bye, guys.